World War II stands as a stark reminder of humanity's capacity for both destruction and innovation. The war, which engulfed nations across the globe, was a period of intense conflict and unprecedented technological advancement. It was a time when the boundaries of human ingenuity were pushed to their limits, driven by the dire necessity of survival and victory. The global conflict acted as a crucible, forging new technologies at an unprecedented rate. Laboratories and factories became the front lines of innovation, where scientists and engineers worked tirelessly to develop new tools of war. The urgency of the situation demanded rapid advancements, and the pressure to innovate was immense. Necessity, as they say, is the mother of invention. The dire circumstances of the war forced nations to invest heavily in research and development. This period saw the birth of many technologies that would later become integral to both military and civilian life. The collaboration between scientists, engineers, and military strategists was crucial in turning theoretical concepts into practical applications. With millions of lives at stake and the fate of nations hanging in the balance, scientists and engineers on all sides were pushed to their limits. The race to develop superior technology was not just about gaining a tactical advantage, it was about ensuring survival. Every breakthrough, no matter how small, could tip the scales in favor of one side or the other. The drive to outmaneuver and overpower the enemy spurred a relentless pursuit of technological advantage. From the development of more efficient weapons to the creation of advanced communication systems, the war effort was a catalyst for innovation. Engineers and scientists worked around the clock, often under immense pressure, to deliver solutions that could change the course of the war. The war effort demanded radical advancements in weaponry, communication, and strategy. New technologies such as radar and encrypted communication systems played crucial roles in military operations. These innovations not only improved the efficiency and effectiveness of military strategies, but also laid the groundwork for future technological developments. Existing technologies were refined and adapted for military purposes, while entirely new fields of research emerged. Civilian technologies were repurposed to meet the demands of the war, leading to significant advancements in various fields. This period of intense innovation saw the birth of new disciplines and the rapid evolution of existing ones. This relentless pursuit of innovation transformed the battlefield and, in many ways, redefined the future. The technologies developed during the war had a profound impact on the way wars were fought and won. From advanced weaponry to sophisticated communication systems, the innovations of World War II set the stage for modern warfare. The world would never be the same. The end of the war marked the beginning of a new era, where the technologies developed during the conflict began to find applications in civilian life. The innovations that were born out of necessity during the war started to shape the post-war world in ways that were previously unimaginable. The legacy of wartime innovation extends far beyond the battlefield. Many of the technologies that were developed during World War II have had a lasting impact on civilian life. From medical advancements to new forms of transportation, the innovations of the war have continued to influence our daily lives. Many technologies developed during World War II have had a profound and lasting impact on civilian life. Radar technology, for example, revolutionized air travel and weather forecasting. Jet engines, initially developed for military aircraft, became the backbone of commercial aviation. The development of nuclear energy, while controversial, has had far-reaching implications for both energy production and international relations. From the development of radar and jet engines to the dawn of the atomic age, the war irrevocably altered the course of human history. The atomic bomb in particular stands as a stark reminder of the destructive potential of human innovation. The bombings of Hiroshima and Nagasaki not only brought an end to the war, but also ushered in a new era of nuclear politics and global power dynamics. Understanding the technological innovations of World War II is essential for comprehending the world we live in today. The advancements made during this period have shaped the modern world in countless ways. By studying the innovations of the past, we can gain a deeper appreciation for the technological landscape of the present and the potential for future advancements. World War II saw the world divided into two main factions, the Allied and Axis powers. This division was not just a matter of political alliances or military strategies, it was a clash of ideologies and visions for the future. The stakes were incredibly high and the entire globe was drawn into a conflict that would reshape the course of history. The Allies, led by the United States, Great Britain and the Soviet Union, faced off against the Axis powers, dominated by Germany, Japan and Italy. Each side brought its own strengths and weaknesses to the battlefield, and the outcome of the war would hinge on their ability to leverage these assets effectively. This global conflict became a technological arms race, with each side vying for superiority on land, at sea and in the air. Tanks, naval ships and fighter planes became symbols of power and progress, each new model representing a leap forward in engineering and design. The skies, seas and battlefields were transformed into arenas of relentless innovation and competition. The race for technological dominance was a matter of survival. Every new weapon, every new piece of equipment could mean the difference between victory and defeat. Soldiers on the front lines relied on these advancements to gain an edge over their adversaries, and the pressure to innovate was immense. Each new breakthrough had the potential to shift the balance of power. A single innovation could turn the tide of a battle or even the entire war. Military strategists and scientists worked hand in hand, constantly seeking ways to outmaneuver and outgun the enemy. The stakes were nothing less than the future of the world. The Allies and the Axis poured vast resources into research and development, enlisting their brightest minds in a desperate struggle for an edge. Laboratories and research facilities became the front lines of this technological war, where scientists and engineers worked around the clock to develop new weapons and technologies. Scientists and engineers worked tirelessly, driven by the knowledge that their innovations could determine the outcome of the war. The pressure was immense, but so was the potential for groundbreaking discoveries. Every experiment, every test was a step closer to a new advantage on the battlefield. This technological competition was not limited to weapons of war. Communication devices, medical advancements and logistical innovations were all critical components of the war effort. Effective communication could coordinate complex operations, medical advancements could save lives, and logistical innovations could ensure that troops had the supplies they needed. It extended to areas like communication, medicine, and logistics, all of which played crucial roles in the conflict. Radios and other communication devices allowed for real-time coordination of troops and strategies. Medical advancements, such as new surgical techniques and antibiotics, saved countless lives on the battlefield. Efficient logistics ensured that armies were well supplied and could sustain prolonged engagements. The pressure of war fostered an environment of intense innovation, leading to advancements that would shape the post-war world. The urgency of the conflict accelerated the pace of technological development, resulting in breakthroughs that might have taken decades to achieve in peacetime. These innovations would go on to have lasting impacts, not just on military technology, but on the civilian life as well. The lines between military and civilian applications blurred as technologies developed for the battlefield found new purposes in peacetime. Radar, initially used for detecting enemy aircraft, became a staple in weather forecasting. The development of penicillin, driven by the need to treat battlefield infections, revolutionized medicine. The war's technological legacy continued to influence the world long after the conflict had ended, shaping the modern era in ways that are still felt today. One of the most significant technological breakthroughs of World War II was the development of radar. This technology fundamentally changed the way wars were fought, providing a strategic advantage that was previously unimaginable. Before radar, militaries relied heavily on visual sightings and acoustic detection, which were often unreliable and limited by weather conditions and the time of day. The advent of radar revolutionized these methods, offering a new level of precision and reliability. Radar, which stands for Radio Detection and Ranging, uses radio waves to detect objects and determine their range, altitude, direction, and speed. This was achieved by transmitting radio waves and then receiving the echoes that bounce back from objects. The time it took for the echoes to return allowed operators to calculate the distance of the object, while the direction of the received signal indicated its location. This principle, though simple in theory, required sophisticated technology and precise engineering to implement effectively. This revolutionary technology gave militaries the ability to see enemy aircraft and ships, even in darkness or poor weather conditions. It was a game changer, particularly in aerial and naval warfare, where visibility was often a critical factor. Radar operators could now detect incoming threats long before they were visible to the naked eye, providing crucial time to prepare and respond. This early warning capability was instrumental in many defensive and offensive operations throughout the war. The development of radar was a collaborative effort, with scientists in several countries making significant contributions. In the United States, the Radiation Laboratory at MIT played a pivotal role, while in Britain, the Telecommunications Research Establishment was at the forefront of radar innovation. These institutions, along with others in Canada, Germany, and Japan, pushed the boundaries of existing technology to create more effective and reliable radar systems. The exchange of ideas and information among these scientists was crucial to the rapid advancement of radar technology during the war. British researchers played a crucial role in developing the technology, building upon earlier work on radio waves. Pioneers like Sir Robert Watson-Watt and his team were instrumental in creating the first practical radar systems. Their work laid the foundation for the chain-home network, which became a cornerstone of Britain's air defence strategy. The British were among the first to recognise the potential of radar and invested heavily in its development, leading to significant advancements that would prove vital in the war effort. By the early years of the war, the British had established a network of radar stations along their coastline, which proved invaluable in defending against German air raids. This network, known as chain-home, consisted of a series of radar towers that could detect incoming aircraft from hundreds of miles away. The information gathered by these stations was relayed to command centres, where it was used to coordinate the defence. This early warning system was a key factor in the success of the Royal Air Force during the Battle of Britain. The system, known as chain-home, provided early warning of incoming enemy aircraft, allowing the Royal Air Force to scramble fighters and effectively counter the Luftwaffe's attacks. This capability was particularly important during the Battle of Britain, where the RAF's ability to intercept and engage German bombers before they reached their targets was crucial. The chain-home network not only helped to protect Britain from aerial bombardment, but also boosted morale by demonstrating that the country could effectively defend itself against a formidable enemy. The impact of radar on the course of World War II cannot be overstated. It transformed aerial warfare, giving defenders a crucial advantage in intercepting enemy bombers. Radar allowed for more coordinated and effective air defense strategies, reducing the effectiveness of enemy bombing campaigns. It also played a significant role in offensive operations, enabling more precise targeting and navigation for Allied bombers. The ability to detect and track enemy movements in real time was a game changer. Altering the dynamics of the battlefield, it transformed aerial warfare, giving defenders a crucial advantage in intercepting enemy bombers. The ability to detect incoming aircraft from a distance allowed for better preparation and response, significantly reducing the damage caused by enemy raids. Radar-guided interceptions became a standard tactic, with fighter planes being directed to their targets with unprecedented accuracy. This technological edge was a key factor in the Allies' ability to maintain air superiority throughout the war. Radar also proved vital in naval warfare, allowing ships to detect enemy vessels and avoid collisions, particularly during nighttime engagements. The ability to see beyond the horizon and through the darkness gave naval commanders a significant tactical advantage. Radar was used to guide ships through minefields, coordinate fleet movements, and detect enemy submarines. This technology was particularly important in the Battle of the Atlantic, where it helped Allied convoys evade German U-boats and ensured the safe passage of vital supplies. The technology played a decisive role in key battles, including the Battle of Britain and the Battle of the Atlantic, ultimately contributing to the Allied victory. In the Battle of Britain, radar provided the early warning needed to repel the Luftwaffe's attacks, while in the Battle of the Atlantic it was crucial in protecting convoys from submarine threats. The successful implementation of radar technology not only saved countless lives, but also ensured the flow of resources necessary for the war effort. Its legacy continued long after the war, laying the groundwork for modern radar systems used in both military and civilian applications today.